Hi everyone, externality video. So we did the introduction, we're now on here. Excellent. This is the fun one with lots of diagrams. Next slide. Some definitions first. Externality is a consequence of an industrial or commercial activity which affects other parties without being reflected in the market price. Other parties. That essentially means the third party. So I think I said this in the introductory video, introduction to market failure. The first and the second party are the ones involved in the transaction, in the as it says there, the commercial activity. So the easy example would be a first party might be a firm making cars. Second party is the personal whatever buying the car. That's the transaction. And then the third party is somebody utterly unrelated to those two people or entities, whatever, actors, who gets affected positively or negatively. And we'll get on to a lot more of that in a minute. And here we go. Private cost benefit is the cost or benefit of an activity to an individual or an economic unit. So you know, for the firm, that'll be, you know, making the car. Might be a cost like metal for making the car or rubber for the tires. Benefit, you buy a car, you get a benefit, I suppose, as an individual. And then we have the social cost and benefit of an activity to society as a whole. So and you're going to see this when we get onto the diagrams, and it tends to be in terms of marginal, doesn't it? Social cost, for example, is going to be the marginal private cost plus whatever the marginal external cost is. And you'll see this in a diagram. You've got the private cost, private to the firm, and you add this external cost, this third party cost, and then you get the total cost to society, society as a whole. Really important. Probably much clearer when you see it in a diagram. Difference between private and social costs and the private and social benefits is the externality. Okay. Although the difference between these two, private and social costs, is going to be the marginal external cost, and in another colour, difference between the private and social benefits is going to be the marginal social, it's probably marginal external benefit. You'll see this in a diagram in a minute. More definitions. Negative externalities. So negative, there's the third party. Negative third party effect, also known as an external cost. I quite like, well, you'll see when we do the diagrams, you use marginal external costs. These goods can be over provided in a free market, e.g. smoking causes passive smoking, which is a demerit good. Demerit good's a phrase meaning a bad good, really, and we should produce and consume less of them. So you know, the first party is, I suppose, the company making cigarettes. The second party is the person who bought the cigarettes and smokes them, and the third party is some random person who just breathes in the passive smoke, and they're nothing to do with it, and they get that negative cost, external cost. They're external to the initial transaction. Positive externality is a positive third party effect, also known as an external benefit. These goods will be underprovided in a free market. So pollination of surrounding crops by bees kept for honey. That's nice. Merit good, things that are good for you. So you may be a beekeeper and you're doing it, you know, it's a business. You want to make honey, and there's somebody out there, the second party, who's consuming the honey. They enjoy buying the honey. But there's a third party out there, perhaps there's a farm nearby, and the bees will pollinate other crops. They're getting that benefit for free. It's an external benefit, external to the transaction, the market activity going on, which is making honey using bees. Next slide. Production externalities. So now we've determined what a positive externality and a negative externality is. Now we look, there's an external cost as a result of production, an external cost as a result of consumption of something, and also an external benefit as a result of production and an external benefit as a result of consumption. We're going to see 4 diagrams shortly. So production externalities, third party impact credited by the point of production, and consumption, and third party impact credited at the point of consumption, so like vaccinations. I think this bit about curves, I think what this is meant to say, well, the way I read it, is the supply curve is the cost curve, and that is the one that shifts. And the demand curve is the benefit curve, and that's the one that shifts. That's the way I read that, as you'll see in the diagram shortly. Oh, and then a nice little table with some examples. I don't know what ones you did in the lesson, but I've added some on the next slide. There we go. And there are loads, but here are just some. I did 3 of each. Let's do the classic one first. Negative in production, pollution, air pollution. So a factory blurting out pollution, industrial waste, methane emissions. That's a classic one. That's the cows farting, you know. So the production is production of milk or beef, I suppose. But unfortunately, the negative externality, third parties, methane, bad for the environment. And you're going to see in the diagram, in all these cases, the MSC is greater than the MPC. So the cost to society is greater than the cost to the individual, the firm in question, producing this good. Society has to bear the cost of the methane or the air pollution, etc. Let's do the other classic one, which is positive externality in consumption. Most of the time, I've seen this. University education is the most classic example. You consume education. When you lot go to university, that you'll be buying the product. The producers are the universities, but there's an external benefit to society as a result of you being educated. So the benefit to society here is greater than the benefit just to you, the private benefit. Vaccines, classic recent example. Mosquito nets are similar. I know that in the slides coming up, Ms. Fujiwara used the university education example here for a positive externality in production over here, and that sort of makes sense because, you know, education is produced. That sort of makes sense, but certainly I think the reason why she did that deliberately is because it has come up in both situations in exams, so it's just a bit worth bearing that in mind. So negative in consumption, pollution from cars, classic. Somebody produces a car, somebody buys the car and uses it, they consume the car. But unfortunately, other people have to put up with the pollution. It's a third-party effect. It's negative as a result of consuming cars. Household waste, you consume things and there's waste, that's bad. And we just did the passive smoking one, didn't we? In this case, because it's a bad thing in consumption, your private benefit is actually greater than the benefit to society. The overall benefit to society is less than the private benefit because there's this negative thing going on. And over here, positive again. Company builds a new runway, they're making money, they're happy, but there's a benefit to other people who use it in the future. If a firm provides first aid training to their staff, they're happy with that because it's going to help within the firm, but there might be external benefits if someone collapses, I don't know, in the street and you help them. Totally random person who's nothing to do with the firm. And same with training. A firm will provide training to their workers because it's good for them, but then if that person then gets another job elsewhere, that training is still, you know, that person still has that benefit, as it were, is more productive worker, and some other firm benefits. So in this case, the marginal social cost, because remember we're talking about production, is less than the marginal private cost, because we've got a situation now where, unlike here, where the cost to society is higher than the private cost, now we've got a benefit so the cost to society is lower than the private cost. This benefit has reduced the cost to society in a sense. So much clearer the diagrams coming up. Okay, and what Ms. Fujiwara did here is she does a step by step. I'm going to flick through this pretty quickly. Here we go. Draw free market equilibrium. Her example for this diagram is chemical plant releasing toxic waste. Okay, fine. And it goes in a nearby water source. That's really bad. This makes the water filtration process lengthy and expensive. It also impacts on aquatic life, reducing its population. And we just said that MSC is greater than MPC. Draw an MSC curve that's essentially above MPC. Mark the point where E2 is going to be the socially optimal equilibrium, and then can you identify whether the price has gone up and down, dead weight loss. Right, we're going to see this in a minute. So for this one only, I'm going to draw the diagram as we see it. For the others, I'm just going to use the diagram. So negative externality in production. You start with a demand curve and a supply curve, and that gives you P1 and Q1. Now, I suppose the point is, I might move to blue now. This demand curve is really known as the marginal private benefit curve. And in this case, because it's a negative production externality, because it's in production, it's going to be the production curve, the supply curve that shifts. That was on the slide previously. So I'm going to assume there's no external benefit to society. So this one, I'm just going to write equals MSB. In other words, there's no external benefit. All the action is going to be with the supply curve. So this, the original supply curve is just a marginal private cost curve, private to the firm. This is just the normal supply curve. What this normal diagram you've drawn 100 times doesn't show is this external cost, and we do that by shifting this out. This is the marginal social cost, and in a sense that vertical distance is the marginal external cost. And remember earlier we said MSC equals MPC plus that marginal external cost, that externality. That's exactly what we see here. So here's the marginal private cost, we add on the marginal external cost, and we get to the marginal social cost. Okay, now this new equilibrium, might as well do it in red. I think in the diagrams that come it's P2, Q2, but I quite like P star, Q star, because this star represents, it's the star equilibrium, because that point there, if you notice, is where MSC equals MSB. S here, S here. Social equals social. All four diagrams we're going to draw, the social equals the social at the socially optimal equilibrium. This is the socially optimal equilibrium. And then that thing about deadweight loss. Well, the deadweight loss always, this is going to be true for all four diagrams. The way you measure the deadweight loss is you start at the socially optimal equilibrium, and you go back or forward to, depending on the diagram, the actual equilibrium. So I'm going to draw lots of green lines here until we get to the actual equilibrium. In other words, what we're saying is that all these green lines here represent units that are made that shouldn't have been made. Okay? Remember, and this is a bit confusing, but remember this line here doesn't really exist. The black lines is what's happening. It's where supply equals demand, and there's the equilibrium P1, Q1. So what is happening here is we're producing at Q1, but we should be producing at, I've just noticed this is P down there. It's a bit silly. Q star. So we should be producing at Q star to reflect the fact that this is a bad thing, negative externality in production. But we don't. We produce at Q1. So all these little green lines here represent extra units we made, but we shouldn't have done. And all the green lines here represent units for which the cost of, so let's take this one unit here, say the cost to society is higher than the benefit to society. The cost to society represented by, well, the MSC, but the true cost to society of making that unit at the margin. And that little blue dot there is the benefit to society of consuming that unit. And that gives us that little green line there, which I've now turned purple. And all those green lines do are adding up all that, all those situations, all those goods for which the cost to society of making them is higher than the benefit to society of consuming them. And you add up all those green lines and you get that deadweight loss triangle there. That is how you construct it. So we have the market equilibrium at A, the socially optimal equilibrium at B, with the deadweight loss, the green triangle, or the purple triangle if you prefer. It's all there. Next slide. And there it is, all done nicely. Like I said, I sort of quite like this to be Q star and P star, because that there is where MSC equals MSB. It's the equilibrium. It's the socially optimum equilibrium. Sadly, this is where we end up, where basically supply equals demand. Next slide. Oh, sorry, we've got the key. Free market outcome, Q1. There we go, socially efficient outcome when MSC equals MSB. It's the socially efficient outcome, and the deadweight loss is that orange. It was green on my diagram. Next slide. And again, I'm going to skip through this because we're on 14 minutes. It looks like the example here is going to university. Remember I said that Miss Fijiwala has done this as a positive production externality, essentially assuming that the education is produced because look at this expansion of higher education. The government essentially deliberately produced more education, so it can be thought of as a positive production externality, although I've seen a lot of questions where it's a positive consumption externality, but still. And this is just describing the drawing. We're running out of time, so I'm just going to go to the diagram. And here we are. So this time it's still production externality, so it's still this bit that shifts. If I adapt this to be a bit like my diagram, demand equals MPB equals MSB, i.e. no external benefit is assumed in consumption, or cost for that matter. So now notice the MPC is here and the MSC is below, because this is now positive things, the costs are reduced. Remember those examples we had earlier? And the other thing I want you to note is the E1 again is just the equilibrium, because guess what? It's where supply equals demand. But where MSC equals MSB, notice social is here. That is the socially optimal equilibrium. And just like in the previous diagram, although we're going the other way this time, notice the deadweight loss starts at the socially optimal equilibrium, and this time goes back to where the actual, sadly, the actual equilibrium is going to be. And again, we're going to have these lines. I might do them in red actually. These lines here, which represent these units here. And this time it's the other way around, isn't it? This time, these are units we didn't make, because we're at this equilibrium here, aren't we? So we'll put all those units between Q1 and Q2. Remember, I sort of prefer Q star here, because that's the socially optimal. All those units between Q1 and Q star, or from the actual equilibrium to where we would rather be, because there's this positive externality. All those units, we have a situation, I'll do the same things I did last time, where this time the benefit to society, represented by say A, is for that unit, is higher than the cost to society of making it point B. So that line AB represents a sort of benefit foregone. Does that make sense? So we're at Q1, that's the actual equilibrium, sadly, but all these units down here, we wanted to produce those to get all those benefits, all those purple lines here. So I don't like, I mean, textbooks call this deadweight loss. They always call it deadweight loss, but when it's a situation where the equilibrium output is lower than the socially optimal level of output, really what we should be saying is benefit foregone. These are units we do not make, but it's a shame we didn't make them. So deadweight loss, because deadweight loss implies something's lost. This isn't something lost, it's something we never had, because we didn't make those units. Right, 17 minutes, I need to get a move on. Next slide. Again, I'm going to skip through this. Positive consumption externality. Example used here looks like electric cars. So next slide. So now this is consumption of an electric car, and this is good for society. You know, the fact that there's no pollution and what have you. So now we've got a situation where this isn't moving. So MPC equals MSC. No externality in production. All the externalities in consumption is positive. So if we just do demand equals supply, we get E1. It's the same in every diagram, but if we do MSC versus an MSB, we're at this one. That's the socially optimal one. So that's where we want to be. That's why I quite like Q star and P star. And just like all the other ones, you start at the socially optimal and you go back to the actual. And again, this is going to be one where we're at Q1, we want to be at Q star. So sadly, these are units that we would like to make, but we don't, or like to consume, but we don't rather. And so this is, again, benefit foregone, although it's in textbooks, they call it deadweight loss, but again, it's benefit foregone. Because sadly, the equilibrium is going to be at Q1, but the socially optimal one is at Q2. So you see the repetition of the analysis. You will at some point be looking at solutions to these problems. Next slide. Oh, this one's got the key, like we had before. Yeah, okay, we settled that already. Okay, Last one. Again, I'm going to fly through all this. And again, let's have a look at the example. This is negative in consumption. So it looks like, yeah, it looks like smoking, nicotine consumption, passive smoking. We've said this 3 times now. Let's have a look at the diagram. Again, we've got demand equaling supply to give our E1, our equilibrium, but you know, there's negative externalities. So this MSB, the benefit to society, is lower than the private benefit because of the costs. Remember, we're going to write here equals MSC because we're assuming there's no production externality. So this is our Q star. It's where we want to be, P star. So that is the socially optimal equilibrium, where, guess what, MSC equals MSB, the social here equals the social here. It's the same every diagram. And finally, same with all the other diagrams, you start at the socially optimal place and you go back to, or in this case forward to, what it ends up being the actual equilibrium to get the dead weight loss. It's the same in all 4 diagrams. This time we're making too much, or in this time consuming too much. So all those little extra units, this is now a proper dead weight loss, because that is, sadly we're at Q1. It would be optimal to be at Q star. So all those green lines represent, as we said in the first diagram, I think, positions where, for instance, say at point A, whatever unit that is down here, point A is the cost to society of consuming, in this case, cigarettes, and B is the benefit to society of consuming these cigarettes. So the gap is I mean, that's bad, isn't it? You don't want the cost to society to be above the benefit to society for that marginal cigarette. So that's bad. And if you add up all those purple lines, or rather the green lines I drew, you get the whole triangle. We're 21 minutes, it's too long. Next slide. Yeah, there's some questions here which I think you must have done. I'm not going to dwell on these now. To what extent does market failure occur in tobacco industry? To what extent does market failure occur in education? To what extent does market failure relate to result from the consumption and production of sugar? So I think Miss Fiji Waller's just given examples here of all the different types of, well, I mean, and you could probably think of others. To what extent does market failure occur in, and then fill in the blank, whatever industry, whatever sector. Yeah, these are pretty classic examples. And in the final slide, it looks like you probably pick one of those as a 15 marker, and you can see up here the way to approach it. You've got K, and this is how it's marked, KAA, and then evaluation, so it's 9 plus 6 really. Remember, this would be levels based marking. Most of you are going to get to at least level 2, probably level 3 in your explanation, if you remember to do 2 points followed by 2 evaluation. You're probably going to use a diagram. Anyway, we're going to do loads of that in the future. I'm going to finish there because we're almost 23 minutes, and I'll speak to you soon. Bye.